Good afternoon, everyone. How's everybody doing? Oh, all right. All right. You guys are pretty awake this late in the day. Tech Ed, Orlando. Been looking forward to this one for a long time. We've got a lot to talk about. I'm Jeff Woolsey. I'm a Principal Program Manager lead in the Windows Server and Cloud Division. I have the pleasure of working on virtualization now for over 15 years. Before Microsoft, I worked at a small startup. We made this thing called Virtual PC. Way back when people wanted to run, this is for the guys, not the youngins out here, but this is for folks that wanted to run they wanted to run DOS on their Power Mac 6100s and their Windows 3.1 on their Power Mac 8100s. Not only we did virtualization, but we actually did binary translation, PowerPC to x86. That was really fun. So did virtualization there, and in fact enjoyed it so much that a bunch of us were actually acquired, moved to Microsoft, and we've been working on virtualization. I've been having a ball ever since. I've worked on Virtual Server and HyperV now in Server 2008, 2008 R2, and obviously now in 2012. And very excited to tell you about what's new in Server 2012. So a number of things. Number one, this is a two-parter. So the first part I'm going to focus on scale-up workloads, platform resiliency, storage, automation, manageability. May have a couple little surprises, something that actually hasn't been announced anywhere at any time, so something new for you guys. We also have what's new in Server 2012 Part 2, networking, clustering, mobility, Linux as a guest. Yes, that's right. I have this up here as well. A couple things. I mentioned this in the keynote, but literally can't cover everything in 2 sessions. There's just no way it can be done. I've tried. It just doesn't work. So you'll see in a bunch of my slides, I'll have shout-outs to sessions that will go really deep on one topic. So for example, if guest-side clustering really floats your boat, guess what? I got a ticket in there, and there's the guys doing, the clustering team doing a really deep dive into guest clustering, application monitoring, things like that. Just want to make sure you guys get the most out of this week, because literally we have a ton of content. So really quickly, you kind of saw this morning. I want to just very quickly touch on this, which is we really want to make sure that people understand we are looking at cloud very holistically. A lot of folks tend to look at virtualization and cloud as, oh yeah, we've got a hypervisor, so we're running cloud. I've had a lot of people, you know, we have come to Microsoft, we've got a briefing center, and they say, yeah, we've got cloud, we're using Hyper-V. I'm like, okay, well, tell me what else you're doing. You know, what's your management? What's your policy engine? How are you actually, you know, doing automation? And they kind of give me this blank stare, and they say, we're doing Hyper-V. And that's virtualization. That's great. Love virtualization. But we tend to see that a lot of people get focused on virtualization, the platform itself. And it's really easy to do because, you know what, I can go out and create a bunch of VMs. It's really easy. I can say, you know what, I got 300 VMs, I got 500 VMs, I feel like I've accomplished something. But that's just virtualization. That's really taking physical machines, virtualizing them, putting them in containers, and running them that way. But it's not changing the management paradigm. And I just bring this up because a lot of people tend to focus on the virtualization layer and tend to kind of forget about what's going on above. Very often I'll ask a very simple question. I'll be talking with someone and I say, you know what, how many hosts do you have? How many virtualization hosts? And the CXO sitting here at the end of the table will say, oh, we got 250. Guy sitting right next to him actually says, well, actually no, it's about 450. And the guy sitting down at the end of the table who's actually running the service says, well, it's actually close to 900. And if you can't even tell me an answer to that basic a question, it tells you, well, how can you have any assurance that you're running anything in terms of compliance, in terms of regulatory, in terms of efficiency, et cetera. So don't underestimate management. So building your cloud just got a whole lot easier with Windows Server 2012. One of the things I want to talk about are some of the considerations for cloud and a number of things we heard in feedback from you, in customers, analysts, reviewers. First of all, mission-critical scale-up workloads. If you were at the keynote today, you saw me with 64 virtual processors in a single VM. Also, massive hosts now, 320 logical processors and up to 4 terabytes. Quite simply, we want to make sure that we go after and can virtualize everything. We looked at storage, costs, complexity, security, your data at rest. This is something I hear about all the time. How many times does, whoops, a disk went out the side door. Oops, somebody just lost, a few million passwords to a huge online service. What could they have done to protect that? Things like that. Continuous availability. Uptime is not an option. I'm always reminded of when my daughter, my youngest daughter, came in when she was only 4 years old, and she wanted to go to sesamestreet.com. So I went to sesamestreet.com, clicked enter, and started to walk away. And I heard this, "Daddy, it's broken." And I turned right around, and I walked on over, and then it came up. It took like an extra second or two to come up, and instantly she thought it was broken. And right there, it all clicked for me. It's like my kids, our kids, if it's not up right now, then it's broken. Continuous availability is an absolute must. VM mobility. This is something you guys told us about in spades. We love VM mobility. Do more for VM mobility. Make it easier. Make it more accessible. Okay. Networking. Huge amount of pain and heartache here. And we know this as well running our own data centers. Anytime people have to go touch the router, have to go change some tables, there's a little angst around the place. Whoops, someone fat-fingered an error. Whoops, what just happened? Why is this subnet down? What can we do to provide multi-tenancy as well? Because as we start to move to this dynamic world where VMs are load balancing all over the place, and you're trying to optimize for maybe CPU resources or maybe memory resources or storage resources, guess what? Who knows where they land, and all of a sudden you got Coke and Pepsi on the same server. You got Wells Fargo and Bank of America on the same server. How are you going to deal with multi-tenancy and security in those issues? QoS. Whether you're an enterprise or you're a service provider, QoS is extremely important. Talk about that. Now, what was interesting is after I did the keynote this morning, I actually had a number of people find me afterwards, saw me in the hall, and they said, "Hey, I'm really curious about something. You guys are doing 64 virtual processors in a VM? So did you just take server 2008 R2 and ratchet up the number?" Oh, no. No, 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 no. There's actually a whole bunch of engineering behind that, and I thought that actually fit this talk really, really well. So first of all, scale isn't just more virtual processors. As I pointed out today, I can give you a whole bunch of procs, I can give you a whole bunch of memory, but if I can't give you the I/O to keep it all busy, it really doesn't matter. Live migration should just work. So one thing that people kept telling us over and over again is, we love VM mobility. And one thing I would test this scenario all the time. I would say, look, I've got a shiny new feature X. If I give you shiny new feature X, it's going to do really cool things, but this VM no longer can move. It's locked to this piece of hardware. You can't live storage migrate it, you can't live migrate it, you can't fail over it. It is locked to this piece of hardware. How do you feel about feature X? And the answer was, we want you to take feature X, we want you to shoot it and bury out back and never talk about it again. We expect to be able to move VMs. In fact, we want you to go the opposite way. We want you to make it easier, and I want to be able to move a VM anywhere at any time without limitations. Whew. Okay, that's a real tough one. We'll take on the engineering challenge for that one. Performance must increase with cores. This one always looks silly. Even I feel silly even saying it, but there's a reason why. Because if you don't do this right, if we just literally ratcheted up the number from server 2008 R2, your performance would have maybe gone up, but probably not in a linear way or in a consistent way. That's no good. We don't ship products like that at Microsoft. We need to maximize your investment. Today, when you buy a standard 2-socket server, 8 cores on it, you got 16 cores, add SMT to it, you got 32 logical processors in that system. We want to make sure we can take full advantage of all that hardware. We want to maximize it. And then again, we want to virtualize those workloads considered non-virtualizable. And there's a variety of reasons. It could be scale of the VM. I need lots of cores, I need lots of memory, or it could be requirements within the VM. For example, I need access to my SAN, and it's not a nice SCSI SAN, it's a fiber channel SAN. So what are you going to do for me there? So let's start with some of the work that we had to do to make these huge, mammoth, beastly machines even work. Now before I talk about this on the virtual side, let's talk about this on the physical side very quickly. So there's this concept you may or may not know about called NUMA, non-uniform memory access. And the reason this came to being was late 90s, early 2000s, as we started to move to 2-socket, multi-socket SMP machines, they used to share the bus for all I/O devices, memory, all of your devices on the bus. And what would happen was very quickly you realized there was a whole bunch of contention with processors and resources trying to get access to devices, and it was a real pain. And people realized, oh my gosh, 2 sockets is bad enough. What happens when we want to go to 4 or 8 or, these huge numbers? Well, you need something to actually help manage and provide a solution for that. NUMA was brought about to help hosts scale up the number of cores and memory access. And what happens is memory and processors are grouped in what we call nodes, and allocation, CPU resources and memory allocations are made with best locality. And what I mean by locality is the memory is actually in the same local node as the processor. So you can see here I've got NUMA node 1 and NUMA node 2. Again, this is all physical, all right? In this case, I've got memory that's in the same NUMA node as the processors, and I've got memory that's in the same NUMA node as the processors. So let me show you this in an example, and it makes a lot more sense. The important thing is you want to avoid hopping between NUMA nodes. So this is what good NUMA looks like. This is optimal. You can see in this case, all of the NUMA transactions or all of the memory and CPU allocations are occurring within the same NUMA node. NUMA node 1, 2, 3, 4, they're all looking good. Memory is populated in each NUMA node. That's all goodness. This is what bad NUMA looks like, not optimal. System is imbalanced. In fact, you can see here memory and thread allocations are happening across different NUMA nodes. You can see that NUMA node, there's multiple node hops. You can see that NUMA node 2 has an odd number of DIMMs. So if there's any sort of interleaving that's trying to happen, that may or may not happen and depend on how interleaving occurs on the system. NUMA node 3 doesn't have enough memory, and in worst case, NUMA node 4 has no local memory. So all accesses to memory are going to be remote. And this impacts your scale, it impacts your performance. Now this used to be a lot worse. In the days of front-side buses, this was really atrocious because it meant hopping the front-side bus. Really, really bad. So as we move to memory controllers on the processor, it's gotten better, but you still want to avoid this at all costs. So you want to make sure that NUMA is a key aspect of scale-up systems. In addition, when software developers write their applications, we make them NUMA aware. For example, when SQL launches, the very first thing is it looks at the underlying topology and figures out how best should I do my thread allocations, my memory allocations to make sure I'm not hopping NUMA nodes so I can get you the best performance and scale. So to get us to these huge numbers, 64 virtual processors in a VM, we had to apply the concept of NUMA to the virtual machine. This is actually a huge amount of engineering work that does not exist, for example, in previous versions of Hyper-V. In Server 2012, we now introduce the concept of guest NUMA within the VM. And we present a NUMA topology within the VM that's consistent with the physical topology. And the reason why we do that is we want to present that into the virtual machine so that when you install operating systems, no matter what operating systems, because we do it in an industry standard way, they realize, okay, this is what the topology looks like. So the OS can be auto-adjusting itself and be most efficiency for that NUMA topology. And when you install scale-up applications, they'll take advantage of it as well. And by the way, scale-up applications now means things like web servers. IIS 8, for example, in Server 2012 is NUMA aware for the first time. And we're seeing some crazy performance enhancements with IIS 8. So we're very excited about that to see that a really super mainstream workload is going to take advantage of NUMA on Hyper-V. And again, the core point here is that the guest knows about the physical topology and the NUMA nodes are aligned with host resources. In addition, just to let you guys know, we do all of this automatically. So when you create the VM, we actually look at the underlying topology. We do all the work for you. That's the good news. You don't need to do anything. Now, the bad news is there's a few out here that are going to say, you know what, I'm smarter than Microsoft and I want to play with all the knobs myself. Okay, we put the knobs in there. The knobs are all there. They're in an advanced option, and you can change your NUMA topologies. You can change your NUMA nodes. You can do all sorts of cool things. Your performance is going to get all wonky. The good news is we have a nice big reset button there. We put that in after the developer preview, after everyone went in there and started playing with the NUMA topology. And one of the interesting bits of feedback we got really early on was you guys were all interested. You guys thought it was really cool. And you realize, wow, we're doing all these cool things. I'm not sure what it's actually doing, but things look different, or it's behaving differently. Sometimes good, sometimes not so good. So we put this real big, easy, use hardware topology button. When you click on that, we will actually, again, look down at the physical topology and make sure that's mapped correctly and put the right settings into the virtual machine for you. So we've done that work for you. So what that means is we're able to translate this to massive scale for you. As I mentioned already, support for 320 logical processors. Just to let you know what that machine is, that's a 16-socket machine. Each processor has 10 cores, and you add symmetric multi-threading. This is a huge beast. 4 terabytes of physical memory. Okay? Not something you're going to pick up as a standard stock item, but we'll support the biggest, baddest ones out there. Cluster scale, 64 nodes, 4,000 VMs. VM virtual machine processor support up to 64 and up to a terabyte for each VM memory. Live migration and live storage migration, I kind of let the cat out of the bag. I'll talk about that later. But this is a big one. One of the big changes we made is concurrent live migrations. Today in Hyper-V, we can do live migration. We've been able to do this for years now, but it's one at a time. So I can live migrate a VM from one server to the next. Now, the safeties are off. You can go as high as you want. In fact, there is no limit. The limit is how much hardware you want to provide. And I'll talk to you about that in just a moment. In terms of servers in a cluster, up to 64. And then finally, I wanted to mention this VPLP ratio. To me, one of the most disgusting ratios on the face of the earth. This has been a marketing tool for a specific other company, we'll just say. And what this really is this is a way to try and basically say, well, I've got a number of virtual machines, I'm going to count those virtual processors, and I'm going to put a ratio between that and the number of logical processors in the server, where a logical processor equals a core or a thread. And the reason why the answer is or is some processors don't have threads. They're just single-threaded. So anyway, in the case of the VPLP ratio, we used to have 8 to 1. Then in Server 2008 R2, we added 8 to 1 for server and 12 to 1 for client. In Windows Server 2012, that number is gone. There isn't one. Go for it. What this means is, if you're running on a server that's 4 years old, maybe the number is closer to 8, 12, 15 to 1. If it's a server you bought yesterday, maybe that number is 25, 30 to 1. If it's a server you're going to buy next year, maybe that number is even higher. The key is, it depends on what hardware you want to bring to the party. Hyper-V no longer has a limit there. There's 32 virtual processors. By the way, I specifically took this screenshot to show you this in Server 2008 R2 to let everybody know that this works with down-level operating systems as well. Yes, that is what you think it is. That is CentOS. Red Hat works just well. SUSE, Linux, 32 virtual procs. But then, of course, we announced today 64 virtual procs. You can see Windows Server 2008 R2. It's hard to actually get all of the CPU and Task Manager there. It's why we had to rewrite it for Server 2012. So we've been very busy there. So let's move to storage. When it comes to storage, there were a number of things you told us that were really important about storage. Number one, leverage storage array capabilities. This is a big one. When we look at the cost of infrastructure in your data center, storage is a key part of it, really key part of it. In fact, if you look at how a lot of large data centers run their data centers, they use direct attached storage because it's really, really low cost, and they employ some sort of replication technology. Well, we also want to make sure that if you buy the high-end storage, that we fully utilize and take advantage of that. Things like, for example, offloaded data transfer. Native access to SANs from VMs. So one of the things that came out in our discussions with you was, look, we've actually virtualized a whole bunch of infrastructure on Hyper-V. Everything's going really, really well. But you know what? We have a certain set of servers over here that are going to stay on the physical metal because they require access to my fiber channel SAN. And in Server 2008 R2, we didn't have a solution there. We want to help reduce the cost of storage. Now, this can very easily become into a religious war. Okay? The file guys versus the block guys, and then it becomes fiber channel SAN versus file-based storage. I don't want to get into that. I like to look at things a little bit differently than that. SANs are great. We love SANs. SANs are awesome. It's why we spend a tremendous amount of work making sure that Server 2012 rocks on SANs. But at the same time, there's a fundamental question you have to ask yourself about storage. And that question is, does every workload in my environment really require a SAN? No, it really doesn't. In fact, very often I'll talk with someone who says, yeah, we spent a few $1 million on this SAN. I'm like, so what's up there? Oh, well, you know, our mission critical SQL, a bunch of things. And then we got our file and our print and our web. And I'm like, whoa, 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 stop. What did you just say? Well, you know, it had so much capacity, so we thought we'd just throw everything on there. And I'm like, well, what happens when you run out of space? Well, then we have to buy the really expensive storage. But you're putting your file and print and your departmental web on there. That doesn't make a lot of sense. So one of the things we want to do is help reduce the cost of storage by really offering great solutions for around things like file and providing more capabilities to take advantage of direct attached storage. Highly scalable virtual disks. This is actually there are two parts to this. Number one, it's the virtual disk itself. It's the fact that today in Server 2008 R2, it's up to 2 terabytes, and people have bumped up across that limit many times. In fact, at Microsoft, we run into this limit a lot because we don't just use VHD for Hyper-V. We actually use it in the iSCSI world. We actually use it for backup. It's our format that we use within Microsoft. It's actually a universal format that we use for block. So we have a very big investment in it, and we wanted to make sure that when we upped it this time around, we actually gave ourselves plenty of headroom. So to provide dynamic high-performance storage, number one, live storage migration. We really want to be able to move your virtual machines and take advantage of any type of storage you have there. Whether it's direct attach, whether it's file, whether it's SAN, this gives you flexibility to move your virtual machines based on the needs of that workload. So for example, if I want to run my workload in a dev test environment and I want to use it on low-cost direct attach, great. If I then want to move it up to an SMB file share because, you know what, I got more performance, I got more IOPS, great. And if I then want to move it all the way up to the high-end SAN, I can do all of that and use live storage migration as the conduit to move it up and down those tiers. Virtual fiber channel. Virtual fiber channel is something that, quite honestly, I was shocked. I knew it was going to be an impactful feature, no doubt about it, but boy, people are just lining up in droves for this feature. With virtual fiber channel, it basically says that large scale-up SQL server, those applications that are living on the bare metal because they need native access to the SAN, can now move into a Hyper-V VM. And I'll talk about that in a minute. Support for file-based storage on SMB. So I touched on this briefly today. I would highly recommend you take a look at what we're doing in the file server. Okay? First of all, think of everything you've ever thought about the Server 2008 R2 or the previous versions of the file server, and I want you to throw it out the window. This is not your grandfather's file server. This is a completely different beast. In fact, one of my only criticisms was I really wish we would have changed the name. Call it anything else. Call it Fire-Breathing Dragon. I would have been really, really happy. Okay? Because this is not your father's file server. For example, in terms of performance, I'm pretty sure we're showing off some pretty awesome storage performance, so I'll be conservative. But we've already publicly demoed over 5 gigabytes per second to the new file server in Server 2012. And I think this week we're actually showing a much bigger number. But let that sink in for a second. 5 gigabytes, not bits, bytes per second. We're now talking DVDs to my file share per second. So we're talking crazy performance. In addition to the traditional classic file server, we also have the new scale-out file server. With the scale-out file server, you can have 2 nodes, 3 nodes, 4 nodes, how many nodes you want fronting the file server. You can add, you can remove. It gives you continuous uptime due to the intrinsic nature of scale-out architecture. Also, we have great capabilities in terms of thin provisioning, trim and unmapped support, all sorts of really great things. But the most important thing to understand with Hyper-V is now SMB is a first-class citizen. In Server 2008 R2, we don't support file at all. It's block-based storage. It's iSCSI. It's fiber channel SAN. You guys told us loud and clear, we want to provide access to low-cost storage. In case you're wondering, by the way, why we didn't support SMB in the previous releases, is because we actually made changes to the SMB protocol itself. SMB3, there's a reason it's called SMB3 versus SMB 2.2 or 2. etc. It's because this is a huge release. Multi-channel support, resiliency capabilities. Resiliency is extremely important when you're running virtual machines and you get a blip in connectivity that's not very forgiving and you're down for 10, 20, 50 seconds, 30 seconds, even longer. You've got to make sure you've got resiliency handles and capabilities underneath with the SMB protocol. That's exactly why we designed it and put that in the protocol itself. The new VHDX format itself gives us incredible scale. 64 terabytes per virtual disk. This gives us plenty of headroom going forward. Online meta operations. So how many developers do we have in the room? Any developers at all? Oh, a number of you. Okay. You're going to love this feature, especially when you run client Hyper-V. Okay? So for example, one of the things that we can do today is we can now online merge snapshots. You can merge your snapshots live without any downtime. In fact, pretty much everything now is hot in Server 2012. Live VHD merge, live new parent, these required downtime in the past. One thing I want to alert you to is native 4K disk support. I'm a little surprised at how underreported this has been in the industry, but we're on the cusp of some really big changes going on in storage. And I mean talking at the very physical disk level itself. For years, disks have been 512 sector size. Then we have these 512E sector sizes because capacity is getting larger. Well, what a 512E drive really is, it's a 4K drive that pretends to be 512 on the front. The E is for emulation because it's emulating a 512 drive, but on the back it's 4K sector size. The reason I bring this up is because soon we're going to be shipping, hard drive manufacturers are going to be shipping only 4K, there'll be a transition time of course, but they're going to be shipping 4K sector drives. Why is this important? This is important because almost no operating system today supports 4K disk drives. Let that sink in for just a second. Almost no shipping operating system, no version of Windows today shipping supports 4K drives. Server 2008 R2, Windows 7, you put it, try to install it on a 4K drive, setup doesn't even know what it is. Won't install it. So not only does Server 2012 and Windows 8 support it, but Server HyperV will support it as well. So what you want to do is you look around the landscape of your infrastructure and you've got those old workloads out there. Now's a great time to start migrating those to Hyper-V, run them in virtual machines, and we'll take care of making sure they run on 4K and run really, really fast on 4K. Offloaded data transfer, I'll get to that in just a second. So here I am actually. So ODX. ODX, I have to say, incredibly excited about this. You saw it today. I mean, the numbers are astounding. You got two identical configurations there. One of them's doing pretty well, 70, 80 megabytes per second. But you could see the CPU utilization. You could see the network utilization. We completely thrashed and used the entire gigabit for the copy. With ODX, we're leveraging the SAN array capabilities. We're actually talking to the native SAN arrays, and here's how it works. When we do copies, for example, we'll go to the server today. The way we do it in 2008 R2 is we go to the server, we find the file, we read and write. We read and write. The server performs all the I/O, it's doing all the transactions, it's doing all the buffering, all the copying, all the overhead is going on there, but it's being copied and it'll be correct. With ODX, the server actually goes to the array and says, "Array, do you support ODX?" The array comes back and says, "Why, yes, I do." Fantastic. Here's a secure token. Go make this copy happen, and just give me some progress status reports during the copy and let me know when you're done. So instead of the server actually doing all this reading and writing, the array is doing it on the back end. In some cases, it could literally be moving pointers. Okay? So now, all of a sudden, all that I/O, you're not clogging up your I/O. The server doesn't have to do it. The array's doing it and can do it much more efficiently than we can. ODX is great and for copy environments, but it's also used for a whole bunch of other scenarios. For example, Hyper-V. For example, fixed disk creation. So today, when we create a fixed disk, Hyper-V always zeroes the disk. We do this for security reasons. Okay? So for example, if I want to create a 10 gigabyte fixed disk, we create a single 10 gigabyte file and we zero that thing out. Today on a standard desktop machine, it takes about 3 minutes. On an ODX system, I asked the storage guys to show me this, and literally they were like, "Jeff, don't blink." I was like, "What?" Click, done. Something that took 3 minutes, less than a second. And we use it for a whole bunch of other features as well. So fixed disk creation, but dynamic expansion as well. So if you're using dynamic disks, which are now the default, by the way, and the reason why is because performance is phenomenal with the new VHDX dynamic disks, but now we'll take advantage of ODX to do the growing, so it's essentially free. VHD merges, VHDX merges, and live storage migration. So if you want to live storage migrate, we'll automatically do the work under the covers. Now, one of the things I want to mention is, because every time I talk about ODX, someone says, "Where is the ODX button? Where is that thing?" Well, I want to make sure that's on. It's automatic. There is no button. That's why I bring this up. There's no button. We automatically negotiate with the storage and make sure if it's there, we use it. If it's not, no problem. We just fall back to the way we've always done it, and it just works transparently. That's the way it should work. And you can see when you compare what we've done in terms of storage, it's just a huge, massive a sea of change across the board. Live storage migration, as many as you want. VMs on file storage, now with SMB3. Guest fiber channel, yes. Virtual disk format, crazy, 32x greater than what we had previously. Guest clustering, I'll get to in a moment. Native 4K disk support, live VHD merge, new parent, and secure offloaded data transfer. All there, all built into Server 2012. So, securing data at rest. This comes up all the time. I'll be in a room with a CXO, a whole bunch of folks, and they're like, you know what? I get the whole cloud thing. I really do. I think it's great. We want to pool our resources. We don't want to think about racks anymore. We don't want to think about infrastructure in the old way of server here, server there, server everywhere. We want to think of virtual resource pools. We want to think of dynamic optimization. We want to think of policy-driven infrastructure. We love that. But we're having a real fundamental problem with something. And it always comes to this, security. And so the question I always get is, so look, I have good processes in place. In fact, I hire only the best people. We do background checks based sometimes, when I talk to folks who work in financial industry or in healthcare. But you know what? Are there any other safeguards you can help me use to protect my data? I'm not worried actually about the bad guy. I'm actually worried more about the whoops moment. The, oops, we have some data leakage, go out the side door, and now we're in big trouble. Let me give you a real example. A US power company. They had some disks ended up being sold on eBay. Now, this is a good company. They had processes in place. They did their due diligence. In fact, they used physically destroyed drives or scrubbed them to US DoD standards, either by degaussing or overwriting the data a minimum of 3 specified patterns. So they knew what they were doing. And what happens is they get new servers in, and their old servers would go to a third party to be destroyed, removed, data removed, and then possibly in those cases, disks sold on eBay. Well, what happened in this case was they were given to the third party. The third party just, whoops, they didn't go through the process. They sold them on eBay. All of a sudden, people had confidential information. They had PCI card information, payment card information data, memos, correspondence, you name it. Things you really, really don't want happening being sold on eBay. And according to Gartner, about a third of companies use external third parties to dispose of their old hardware. One other example, this one more recent. I get this one all the time. Well, oh, Jeff, come on, US power company, we don't even do that. We're better than that. Okay, here's an even better example, HIPAA. Anybody here under regulatory compliance like HIPAA or SOX or FISMA or, yeah, lots of hands here. Okay, so HIPAA, stolen breach hard drives. So March 2012, just a few months ago, a large medical provider in Tennessee is paying $1.5 million to the US Department of Health and Human Services. Why? Because 57 hard drives were stolen that contained protected health information for over 1 million downloads. This is the most personal and private information you can have. All your diagnosis, all your personal information. This was secured by security patrols. This was secured by biometric scanner, secured by key card scanner, secured by magnetic locks, and keyed locks. And yet, guess what? It still got out there. And their defense was, well, look at all these things we did to help protect the data. And the Department of Health and Human Services says, yeah, that's nice, but the data still got out. $1.5 million, please. So 71% of healthcare organizations have suffered at least one data breach within the last year. That's a pretty sobering number there. So when we look at this, Microsoft, we said, we can do better. Let's see what we can to actually help customers and help avoid this inadvertent data leakage. That's why we're providing a critical safeguard for the cloud with BitLocker encrypted cluster volumes. This is the first time we've ever done this. BitLocker is shipped for many releases. We've had it on 08, 08R2. In fact, it's used by the military regularly. When they go into combat with their servers, guess what? They're all encrypted with BitLocker. If I have to make a sudden retreat, I stick a grenade on the server and head that away. That's standard operating procedure. However, if the grenade doesn't go off, or if it doesn't completely take out the server, it doesn't matter. Because if the bad guys pull out the server, the hard disk, put it in theirs, the only thing they can do is put in the BitLocker key or format the disk. That's it. So we want to bring this tried and true technology to everybody, but do it for clustered volumes as well. So now think about it. You can create the biggest, baddest clusters, 64 nodes, 4,000 virtual machines, and encrypt the data at rest. This integrates with clustering. This integrates with group policy. This integrates with Active Directory. And of course, this integrates with Hyper-V. One of the questions I get asked all the time about this is, yeah, but what's the perf impact? We actually had to put in special instrumentation to find the perf impact. It's actually less than 1%. It's 0.001, I believe, was the number. I couldn't remember if there were 2 or 3 zeros in there. But you can't even tell. It's essentially encryption for free, a great way to protect your data at rest, something you should definitely think about when you're deploying your clouds. HA. HA is something that we have long said you've got to deploy when you deploy virtualization. It's one of the reasons that early on we made HA table stakes. We want to make sure that everybody, if you're deploying virtualization, deploy it with high availability. Planned migrations are great, but it's those unplanned migrations you want to make sure you have a solution for as well. And your input on HA was very clear. VMs need access to fiber channel SANs as well. Legacy apps that don't support clustering, what do we do about those? We've got some apps that were written either internally or by a third party. That company's no longer in business, so they're never going to upgrade it, or we're never going to get clustering support, or yeah, they have a new version that will support clustering, but the budget won't allow for it until sometime down the road. Are there any things that we can do to improve support and health monitoring for those applications? Can we ease integration with SAN replication and snapshotting? This is actually a very important new feature in Server 2012, is cluster shared volumes and support for integrated filter drivers in the storage stack. Highly scalable virtual disks, big data, real big data. So, some of the availability enhancements across the board. Windows NIC teaming. This, to me, personal fan favorite. I can't tell you how excited I am about this feature. I've been asking for this feature for as long as I've been at Microsoft. And when they told me that, yep, oh, it's here, it's in the box, I'm thrilled. And let me tell you why. Generally what happens is maybe you buy a server and maybe it's got vendor A on the motherboard. And then you go and add a NIC and it's got vendor B. Then you try and team them. So you call vendor A and saying, hey, I'm trying to team with vendor B, and he says, whoops, sorry, we don't support that. You call vendor B and say, I'm trying to team with vendor A, and he says, whoops, I don't support that. You call the OEM who sold you the hardware, and he says, whoa, we don't support any of that. So what ends up happening? You got these siloed NICs. Your NICs on the motherboard are doing one thing, they're not teamed, and you got NICs in the PCI slots that are teamed, but the two shall never cross. And if they do and you have a problem, well, good luck getting support for that. With NIC teaming, please, go for it. You can team different vendors, cross-company, it just works. I remember sitting in one of the PM's offices that owns NIC teaming. He said, look, I got a server with 12 different NICs from 12 different vendors. It just works. It's like, awesome. That's exactly what I'm looking for. By the way, we'll support up to 32 NICs in a team. So, yeah, we got you covered there as well. Continuously available file server. As I mentioned, this is not your dad's file server. This is not your grandfather's file server either. Whether it's the classic file server, clustered, or the new scale-out file server, we have solutions in both to make sure that continuously available file servers are there and work great with Hyper-V. CSV integration with storage arrays. Now this one is huge. Let me give you a little backstory behind this. In Server 2008 R2, we introduced cluster shared volumes. Cluster shared volumes allow us to cluster disks so that multiple servers can access the storage simultaneously. And I don't need to create multiple LUNs. So I can create one big LUN, put all my VMs there, point all my servers at it, and go to town. Works really, really well. However, there was one little caveat to it. It didn't work with intermediate storage filter drivers. So for example, your SAN vendor that you do hardware snapshots with, or maybe you do synchronous replication with, he says, yeah, we do synchronous replication, and the way we do it is we drop in these intermediate storage filter drivers, which unfortunately we had a little problem with CSV. So we'd go back to the guys that wrote the storage filter drive and say, hey, can you make a few tweaks here to make it work? And the answer was kind of like, well, hold on, this has always worked. So you know what, we said, you know what, you're right. Let's go back in Server 2012, re-architected a couple pieces here in CSV so that intermediate storage filter drivers just work out of the box. So now you want to do hardware snapshots, you want to do synchronous replication, it all just works with CSV. It just is all there, performs better than ever. Guest clustering via fiber channel. One of the reasons why people wanted fiber channel so bad in the virtual machine, I would say, well, can't you use iSCSI or can't you use VHDs, or we have a bunch of different options. And the answer was, well, we're using clustering today and we're using fiber channel today with this application. Or we're using MPIO, or we're using DSM software. There's a whole bunch of reasons why it really needs to be fiber channel. So we said, okay, you got it. That's in the box. Support for concurrent live storage migrations And again, major failover cluster enhancements. And what I mean by that is, honestly, this is a session in and of itself. If you really want to know what's gone on cluster shared volumes, take a peek here. But a couple of big ones I want to mention, which is look at the second tile on the left, cluster-aware updating. Folks, this is huge. Think about this. You got a 16-node cluster, and not the VMs, but the hosts. Now today, if I need to patch those, I can just live migrate those off. I can do that, go patch the host, migrate them back and move it. And I can do this. It's a manual process. I could script it as well. In Server 2012, we do all the work for you. This is now an automated action. With cluster-aware updating, you basically set up the cluster and say, I'm going to configure automatic updating. And guess what? It'll go to node 1, put it in maintenance mode, drain all the VMs off, download the patches, install the patches, reboot, go to node 2, move all the VMs back over to node 1, drain it, do the same thing, and go through every node in the cluster for you automatically. This is all in the box, folks. This is all built into Server 2012. So if you do go to WSV 430, which I would definitely recommend, give them a little hug. Just tell them Jeff sent you, okay? It's really, really cool. I mean, once you see it, you can schedule it, or if you just want to sit there and watch it and do it yourself, it's actually cool. Just click. You can say, let's do this right now. And you just watch it. Yep, we're going to drain all the VMs off. Let's do it. And it'll just walk through all the nodes in the cluster. So, guest fiber channel. Guest fiber channel, we did a number of really important things about guest fiber channel. Number one, I want to be very clear. This is real fiber channel. This is not some sort of emulated, synthetic, sort of made-up sort of fiber channel. This is real, honest-to-goodness fiber channel. And I bring this up because people come up to us and say, well, can I do failover clustering? Can I do MPIO? Absolutely. In fact, you want to run failover clustering, it'll be supported at the same level as the OS supports it on physical. So it's there. You want to do MPIO? Go for it. If you want to run DSM software like EMC PowerPath or NetApp's DSM software, it just works. Why? Because it's real, honest-to-goodness fiber channel. A couple of things when we were thinking about it is, number one, we wanted to make sure that you applied fiber channel the same way you would a physical machine. So I've had a number of people that have been trying it out during the beta. I get an email, so how do I zone and mask this thing? What do I need to do on the host, and what do I need to do with the guests? And the answer is, you zone it and mask it exactly the same way you would a physical machine. If you know how to zone a physical machine, you know how to zone and mask a Hyper-V virtual machine. We don't want to do anything different. In fact, if you have to do something different, then your virtualization vendor is doing it wrong. Okay? This is how you do it. You treat it and you give it its own zone and mask in a consistent fashion. We do so by using NPIV. This is a capability that's been around quite a while, but we're really utilizing it here in Windows Server 2012. And we're surfacing VM ports on the host. And like I mentioned earlier, you guys love your live migration. So we had to make sure that we solved the problem of making sure that this works seamlessly with live migration, and it does. So if we kind of take a walk up the stack, really what we wanted to focus on was complete redundancy in the box. So at the very base level, we actually have hardware fault prevention protection as well. So this is something we haven't really talked about much. But in Server 2012 and Hyper-V, we can actually detect hardware errors, memory errors. We get an error detection. Hyper-V will actually be notified of the error, and we'll determine what to do with that error. For example, if it's in a VM and it's an uncorrectable error, we shoot the VM in the head. It's done. It's gone. Because you don't want that to poison the rest of the system. If it's actually not been allocated, then no problem. We'll take it offline. We'll map it, never use it again. It never gets used and allocated. Hyper-V is actually doing this quietly and silently. There's nothing you need to do. There's nothing in the UI. As long as your hardware supports it, this is WIA RAS capabilities, we'll do this automatically without any user intervention. Pretty cool stuff. If we move up the level to physical node redundancy, we've got live migration for planned downtime. I'll just move them off because I need to service the underlying hardware, add some more memory, add some more storage, you name it. And we have failover clustering for unplanned downtime. So if I walk up to a server, yank out the power cable, VMs will automatically migrate to other nodes without any user intervention. If we move up the stack again to I/O redundancy, We now have network load balancing and failover via Windows NIC teaming. So your networking is all covered. We have storage multipath I/O. MPO had this for many, many years, very successful. Also, we're introducing multi-channel SMB. This is a big part of the SMB3 push. We wanted to make sure that we fully utilized the channels, the networking capabilities that were available to us, and offer multi-channel SMB for resiliency, redundancy, and better scale. If we then move up the stack even further to application service failover, we've got VM guest teaming of SRIO VNICs. We've got VM guest clustering now. We have iSCSI and for the first time, fiber channel. We also, oh, by the way, I should mention, I've had a couple people ask me, does fiber channel mean fiber channel over Ethernet too? Yes. If you're running fiber channel over Ethernet, and that's what you're running on the physical metal, to the VM, it's just fiber channel. So it doesn't matter what you're running on the root. It can be fiber channel traditional or fiber channel over Ethernet. And also we have non-cluster aware Hyper-V app monitoring. And this is something that the cluster guys will go into detail, something they developed. But really, it's some lightweight health monitoring for those applications that, for example, weren't architected for clustering. We actually can look at the health. If you know you've got an application, for example, that's got a memory leak and it dies or crashes, every 9 days, every 12 days, somewhere in there, you can actually use some lightweight health monitoring to look for that service, keep an eye on it, or if you've got a rogue process every so often, you could kill it and restart it without actually migrating the service. This is actually occurring within the VM. Very cool stuff here. Then, if you go even higher, we've got disaster recovery capabilities. And now we're talking about Hyper-V replica for asynchronous replication. So we've got virtual machines that can actually be replicated to other servers on the same site, other servers that are in another data center that are geographically dispersed. And then we've got CSV integration for storage arrays with synchronous replication as well. So if you look up and down the entire stack, we've got complete redundancy everywhere. So we really have designed this to make sure we are delivering the best cloud OS. Automation and manageability. One thing I wanted to mention very quickly. I didn't have a moment to talk about this earlier this morning, but PowerShell is everywhere. I've mentioned that. In Server 2008 R2 and 2008, we have this concept called core. Anybody ever installed Windows Server in a core deployment? Okay. Pretty painful, huh? Wow, don't all say no at once. No, very true. Very true. As someone who loves the whole concept and core, I've actually spent a lot of time with core. And in 2008, just brutal to try and work with it. In 2008 R2, it got a little bit better. But in 2012, folks, it's all PowerShell. Everything you need to do can be managed remotely via PowerShell. However, there's a couple things that changed in terms of manageability. In Server 2008 R2, when you install the operating system, you get this question. Do you want to install full or core? And it's during OS install, and it's a one-time choice. So if I choose core, that's it. I'm going to get a core, and when I boot up, there's my command prompt. That's it. I can manage it remotely. If I do full, then I'm going to get the full GUI experience, but that's it. I've got full, that's it. In Server 2012, number one, this is now an option. It's removable. You can install Server 2012 and then remove the GUI. You can also install a core installation as well. And then you can also install core and add it later. The goal being here is we want to make it easier for you guys to manage remotely. Make it kind of provide an easy way and transition way to transition remotely and not use the local interface. In fact, do it from your client. Install the remote administration tools. Use System Center. But on the server itself, please manage it remotely. We're making it easier than ever. And with over 2,400 PowerShell commandlets in the box, it's all covered. So, time for one more thing. So, one of the questions I get every now and then is Windows Server, one of the things we love about the fact that Hyper-V is just there. Okay, so I can install Data Center, I get unlimited copies of Windows and VMs, and Hyper-V is there. I don't need to pay for anything. It's simply part and parcel of the package. What do I do with, say, different types of deployments? Say, for example, I want to deploy Linux. I can absolutely deploy Linux on Hyper-V today. It works really, really well, and it's getting better every single day, but it works really, really well. Customers say, the one thing, though, is if I deploy Linux on Hyper-V, that means I'm kind of giving up a slot that I would have used for Windows. So, is there a way that I could use Hyper-V for Linux kind of for free? The other one is VDI deployments. If you're thinking about VDI, if you're contemplating VDI, do I really want to do a Windows Server install because I'm actually going to be running client OSs? I'm not going to be running server OSs, I'm going to be running client OSs. And then there's one more scenario is, you know, I got these IT guys, and they're really good guys, but every so often I catch them doing things that they really shouldn't be doing on servers, like browsing the internet. Okay? I want to kill them. That's the polite way. Wouldn't it be really cool if there was a way I could just deploy Hyper-V, just the Hyper-V bits itself, where they actually can't muck around with anything, they can't install any other services or roles? Okay, we've heard you. In fact, that's why we're announcing, for the first time ever, Microsoft Hyper-V Server 2012. We have released Microsoft Hyper-V Server 2008 and 2008 R2, and we've been steadily watching the download rate for Hyper-V Server just do this. And when I say watching the download rate, is because number one, it's free. We've been giving this away for years. Wait till you see this version. What is Hyper-V Server? First of all, it's an enterprise-class Microsoft hypervisor. Just because it's free doesn't mean it's some random version. This is Hyper-V. This is the real bits, boys and girls. Local command line interface only, does not include guests. Okay? Does not include any licenses for guests. So for example, you want to run Linux, go to town. You want to run VDI, go to town. It's actually perfect for that. Keep in mind, that is your only interface. The reason why is because we want you, in fact, we insist that you manage this remotely. Use Virtual Machine Manager as part of System Center, or you can download the free RSAT tools. Again, we have free management as well, so there's no cost here. It's standalone, it's a free ISO download from Microsoft.com, and it's designed for remote management. But let me be very clear, this contains all the Hyper-V features. What do I mean by that? Well, I've already mentioned some of the great reasons to use Hyper-V Server. Linux VM consolidation. So for example, we talk with folks and say, look, we're substantial, we are a Microsoft shop, but you know, we do have some pockets of other things over here. Great. Put them on Hyper-V Server, and guess what? You can manage them all with System Center. You can manage it all consistently from the same systems management. For VDI, it's a no-brainer. Because guess what? It's a free hypervisor, and you're going to buy client licenses, not server licenses. And if you're a service provider, well, guess what? It's small, it doesn't have anything other than the hypervisor, and you can manage it using the same PowerShell because the Hyper-V PowerShell is the same. So what's in it? Well, how about support for up to 64 virtual processors per VM, up to 4 terabytes of memory per host, live migration, live storage migration, shared nothing live migration, Hyper-V replica, remote FX, storage spaces, SMB 3.0. No clap for any of that? Really? This is 100% free. Number one, the other guys can't even reach this scale. Number two, the closest thing that they have to this costs $3,500 per processor. You don't even get shared nothing live migration from VMware. That's in Hyper-V Server. Shared nothing live migration, massive scale, massive performance. And the thing I want to point out is, look at all of the changes. Over time, what have we been doing? This is all customer driven. More features, more scale, more availability in every release. From 08 to 08 R2, we added live migration, HA, a whole bunch of features. From 08 R2 to Server 2012, honestly, it's almost insane what we're giving away here. So, I have to do the obligatory Now, I'm going to be nice. I'm going to be really nice, and I'm going to be gentle, and I'm only going to compare the free versions. I'm not going to compare it to $3,500 per processor. I'm being a really swell guy here. So let's compare What do you get with ESXi, the free version? You get 4 virtual procs per VM. You're limited to 32 gigabytes of memory for the entire host. You get no vMotion, you get no storage vMotion, you get no HA, you get no extensible switch, you get no VM replication, you get, etc. It's a lot of no's, basically. HyperV Server 2012, up to 64 VPs per VM, up to 4 terabytes of memory per host, up to 1 terabyte of memory per VM. Oh, you're going to keep wanting to take pictures. I'm not done yet. Shared nothing live migration. Live storage migration in the free product. High availability via clustering. Replica. Unlimited replication. And again, this works for other OSs, even Linux. So for all the Linux guys, guess what? We're actually helping them protect their OSs as well. Storage spaces and much, much more. My point being here, this is a no-brainer. It's simply a no-brainer. And the RC bits are available right now. Surprise! All right. Also, one more thing. This kind of generally happens when we talk with people about Server 2012. People are pretty much floored with what they see. And they realize pretty quickly that we're serious about cloud. Cloud is not just a hypervisor. Cloud is looking at things much more holistically than that. That's how we look at cloud at Microsoft. We look at storage, we look at networking, we look at I/O. Yes, we look at the hypervisor, but it's more comprehensive than that. And after people realize, oh my gosh, Microsoft, you guys are the only folks over there that have a private cloud and a massive worldwide public cloud, not something in endless beta that crashes all the time. Real people running in production all the time on Azure. It's amazing what we're getting done right now with private and public cloud, Azure and private cloud with System Center and Server 2012, which naturally leads us to this. So how can I convert from the other guys to you? Now, we've had this capability around for a long time. In System Center Virtual Machine Manager, we have the ability to convert from VMware to HyperV, and there are lots of third parties out there that will do that. There's a number of converter tools. But folks ask us specifically because they want us to stand behind us for support. And in some cases, people say, look, I just want a little tool, something really small. Okay. Virtual Machine Converter Beta, how about 4 megabytes? That's small enough for anybody? It's real small. You download this, and it converts VMware VMs to Hyper-V. And it's not just the disks, okay? There's a lot of disk conversions. That's not the whole thing. You really want to look at the configuration. I want to know, well, this VM had this amount of memory assigned to it, this amount of procs, this amount of NICs assigned to it. You got to move all of that. It's not just disk conversion. The disk conversion is actually easy. It's the configuration and parsing that and making sure that you're moving the entire VM that you got to accomplish. What it does is it converts the VMs, the disks, the configuration. It uninstalls the VMware tools on the source VM and installs the Hyper-V integration services for you. Keep taking pictures. That's okay. I'll keep it up there for a while. And it includes an easy-to-use wizard-driven GUI to make it real simple. In fact, let me hop on over here and give you a quick peek. Alrighty, so pull out my cheat sheet here. So you can see here's the front page before you begin of the Microsoft Virtual Machine Converter. And this is the current beta. You can download this right now. You can enroll in the beta. It's available up on connect.microsoft.com. Currently supports Windows Server 2003, Windows Server 2008, Windows 7. And of course, that's going to be going up a lot. We're going to click on Next. The first thing I need to do is I need to put in the IP address for my ESX server or my vCenter server, which I'm going to do here. And I need my credentials. Click on Next. Now what it's going to do is it's going to interrogate the server and say, great. Get me the list of virtual machines. Now, for this demo, I kept it real simple, just put one VM on here. But if there was more, or I could go to vCenter and give me the entire list of all the VMs through vCenter or on the specific server itself. So it's found my server. It's running server 2008 R2. I'm going to click Next. Now it's going to ask me what's the final state of the source after when I do the conversion. Do I want to leave the source running, or do I want to turn it off? And once I do the conversion, do I want it to just fire up and start running on the target, or do I want to leave it stopped? Right now, I'm just going to leave it for the defaults of off and off. It's going to validate the credentials. It's going to ask me where you're going to put this. I'm going to leave it in this temp folder here. And now it's going to ask me, okay, I got to put in the server here, which is this. And oh, sorry. And right here, it's going to give me a listing and show me anything here that could be of potential interest to me. So for example, in terms of video memory, it's looking at the video memory that's been assigned to. Am I worried about that? No, not worried about that at all. And it's concerned about the number of floppy drives because the other guys like to attach floppy drives to their virtual machines. We think floppy drives were really cool in 1998. So we don't include those with Hyper-V. So you'll see this warning whenever you do a conversion to Hyper-V because we won't do it. But basically, here I would click Finish. And sometime later, depending on how fast my storage subsystem is, how big the disk is, I will be converted, and I will have converted this from VMware to Hyper-V. So that is a brand new conversion tool that is publicly available now in beta. You can download this and start playing it with yourself. Try it out. Show the friends. A couple things I want to point out. Thank you. It will support converting from vSphere 4.1 and vSphere 5. And it will convert today to Windows Server 2008 R2 SP1 and Hyper-V Server 2008 R2 SP1. Server 2012 support is coming very, very soon. So if you watch the VM Connect site or if you sign up for notifications, you'll be automatically notified when the new version comes out. So, a couple things about Server 2012. Honestly, we're pretty excited with what we're hearing from our customers, from you, from our developer community, from analysts everywhere. The 175,000 downloads I forgot to upgrade, we actually hit over 300,000 downloads right before we went to RC, a record number. So the excitement for Server 2012 is literally off the charts. We had the greatest tap engagement. In fact, one of the questions I get asked all the time is, all right, Jeff, let me ask you this. What's the biggest problem that you've had with Server 2012 with your tap customers? And I said, oh, that's an easy one. The biggest problem is this. We have a select group of tap customers, technology adoption partners. We give them access to bits early. It's a high-touch engagement. We do close support with them. They install, they run their production workloads. And the biggest problem we have was everybody installed it. It's running better than anybody expected it would, and they all want us to support them in production right now. Okay, and actually that was at beta. So we're very excited about this. We've been trying to tell everyone, hold off. We're just about there. The RC bits are available. Certainly hope you've already downloaded, installed, and if you haven't, get to it, okay? Make sure once you leave Tech Ed, you install Server 2012 and start playing with Hyper-V RC immediately. So a few things. Number one, definitive Cloud OS. Whether you look at storage, networking, compute, scale, integration, it's there. New storage options, whether it's SMB, whether it's fiber channel, whether it's the continuously available server, whether it's a scale-out file server, it's all there. High availability throughout the entire stack. We walked up and down the entire tree. You can see we've got complete high availability throughout the entire stack. PowerShell is the automation engine for the cloud. If you want to deploy at scale, if you want to deploy 50 new VMs, are you really going to go through the wizard and create 50 new VMs? Or are you going to write a 3-line PowerShell script and say, boom, give me 50 VMs? That's what you're going to do. Hyper-V Server 2012, the RC is available now. Go to where the Server 2012 RC bits are. Look very closely, and you'll see Microsoft Hyper-V Server is there as well. And finally, the Microsoft Virtual Machine Converter is available. Again, it's available as a beta product. You can download it right now. We'd love to get your feedback. Please do download it. Give it a shot. Again, it's only 4 megabytes, so it'll be done in lickety split. So thank you very, very much. I'll be doing Hyper-V Part 2 here in just a moment. Come by the Hyper-V booth in the pavilion. Get your Microsoft Private Cloud certification, and if you want to follow me, I am on Twitter at WSVGuy. I don't do a lot of tweets. I'm not one of those guys who needs to tell you what I'm having for breakfast. So when it comes to Twitter, it will literally be, hey, check this out. There's something new, something interesting. So follow me at WSVGuy. Thank you guys very much, and enjoy the rest of the week here at TechEd.